College algebra, we are reviewing for a quiz and our halfway mark of the polynomial unit, unit number 4, synthetic division to perform this operation, okay? If I'm looking to see if x minus 2 is the factor, that's the same as looking at x equal 2 as the solution. This is the number that goes outside of my synthetic division, and then I need to represent for a 4th degree polynomial something to the 4th, something cubed, something squared, something x, something constant. So those numbers are 3x to the 4th minus 2x cubed plus 1x squared. There is no x term and there's a minus 12. Okay, that 0 is very important. So bring this 3 down. 2 times 3 is 6. 6 minus 2 is 4. 2 times 4 is 8. 8 plus 1 is 9. 2 times 9 is 18, plus 0 is 18. 2 times 18 is 36. 36 minus 12 is 24. Non-zero remainder. So that means x minus 2 is not a factor. How do I read this answer? This is my x cubed, my x squared, my x, my constant, my remainder. So this final answer is 3x cubed plus 4x squared plus 9x plus 18 plus 24 divided by x minus 2. Okay. Completely factor this 3rd degree polynomial given that one factor is x plus 2. So if x plus 2 is the factor, that's the same thing as saying x equal negative 2 is the solution. This goes on the outside of my synthetic division. This is a 3rd degree. I need something cubed, something squared, x, and constant. So I've got 6x cubed, 19x squared, 16x and 4. Bring the 6 down, negative 2 times 6. Add to get 7. Add these to get negative 14, add to get 2. Multiply to get negative 4, add to get 0. Now what I'm left with, this is my x squared, my x, my constant, and my lovely 0 remainder. So what is this complete factorization? F of x is equal to x plus 2. That's the factor that I knew about. And I'm left with 6x squared plus 7x plus 2. Now the job becomes, can I factor that? Okay, how do I factor that? I need to find two numbers that multiply to give me a 12 and that add to give me a 7. I think 3 and 4 would do the trick on that. So this is 6x squared plus 3x plus 4x plus 2, factor by grouping, 3x, 2x plus 1 plus 2, 2x plus 1. This final factorization is 3x plus 2, 2x plus 1. Final answer to this problem is x plus 2, 3x plus 2, and 2x plus 1. That's the complete factorization of that polynomial. Describe the end behavior. Okay, so if I look at this polynomial, what is the degree? 1, 2, 3. This is a 4th degree, and I have a negative leading coefficient. So that means this thing goes down on both ends. So the answer to both of these questions is negative infinity. The next polynomial is a 1, 2, 3, 4, 5th degree. 5th degree, and the leading coefficient is negative 1. So this is going to be like a negative x cubed. It's going to go up and down. So the answer to this first question is infinity. Next question, negative infinity. Completely factor this next polynomial given two factors, okay? So I need to be able, so I've got x plus 5 as a factor and x minus 7 as a factor. So that means x equal negative 5 is a solution and x equals 7 is a solution. So I should be able to get synthetic division to work twice on this one. So let's set that up. Let's start with -5. Doesn't matter which one you start with. So I've got an x to the 4th, x cubed, x squared, x, and constant. So those numbers are 1, 1, -39, -109, -70. Bring the 1 down. 1 times -5, I get -4. -5 times -4, that is 20. Subtract to get -19, okay? 5 times 19 is going to be 95. And that's going to leave me with -14. And then 5 times 14, negative, that's going to be 70. That leaves me with a 0. Okay. Now, the next thing I need to do, that was the -5. Let's don't stop here. Let's do synthetic division again with that 7. So bring the 1 down. 1 times 7, 7 minus 4 is 3. 7 times 3 is 21. Subtract that to get 2. 7 times 2 is 14. That gives me 0. Okay. So since I did 2 synthetic divisions, this is my x squared, my x, my constant, and my remainder. So f of x is equal to x plus 5, x minus 7, the 2 factors that I know. And then how do you read this bottom row here? That is x squared plus 3x plus 2. Well, if you go off to the side here, x squared plus 3x plus 2 is begging for 2 numbers that multiply to 2 and add to 3. Those numbers are 1 and 2. So this is just x plus 1, x plus 2. So your final answer, f of x equal x plus 5, x minus 7, x plus 1, x plus 2. Okay? That's a long problem, but it's all things that we've done, and you got to be real careful with the arithmetic on that guy. So sketching a polynomial. If I give you a polynomial here in factored form, this guy, the degree is 3. The leading coefficient is 1. The x-intercepts, the roots, the solutions, that's going to be at 3, 0, and -4, 0. I can see that there is a multiplicity of 2 at x equal 3. Okay. The y-intercept, what do you get when x is 0? If I plug in a 0 there, I'm going to get -3 squared times 4. So that's 9 times 4, that's 36. So the y-intercept is the point 0, 36. Now, here's what we need to do with this. If it's third degree leading coefficient 1, what's my end behavior? That guy is going to look just a lot like x cubed. Okay, so it's going to go up in this direction and down on the left side. Okay, so let's graph this guy. The intercepts are at 3 and -4, but I do not cross at 3. So at 3, 1, 2, 3, I'm going to put a red dot. And then at -4, 1, 2, 3, 4, I'll put a green dot because I do cross there. The intercept was at what, 0, 36? Okay. And so is it possible to go, what I need to do is I need to go start at the bottom left, and then end in the top right. So the graph of this guy is going to have to do something like this. And that is within the realm of possibility. Okay. Looking at the next graph. What is the degree of this guy? 1, 2, 3, 4. This is a 4th degree. Leading coefficient is -1. This guy's going to go down on both ends. X-intercepts are at -1, 0, 1, 0, -4, 0. There is a multiplicity of 2 at x equal -1. The y-intercept, plug in x equal to 0, and you get what, 1 squared, -1, 4. So that's -4 times 1. That is 0, 4. And we should be able to graph that. So I do not cross at -1. Okay. I will cross at 1 and -4. I have a y-intercept of 0, 4. And I need to go down on both ends, so is it possible to do what I want? And yes, that is the case. So when I need to graph this guy, it's going to start somewhere down here. It's going to go up and bounce, hit that y-intercept, come down, and never come back, okay? So that's the general shape of this graph. Describing transformations, okay? How do I get from H to Q? Was I reflected over the x-axis? Yes, the sign changed. Did I shift? Okay. If it looks like it, so I was at x plus 3. What happens if I subtract 5, I get to -2. -4 minus 5, I get to -9. 7 minus 5, I get to 2. So it looks like I'm doing a -5 every time here. So -5 is a way of moving it to the right 5. And then this +7 tagged on the end is a way of moving that graph up 7. If I look at the next example, this polynomial, none of this changed. Was it reflected? No, the signs did not change. Did it go left or right? No, the x's are still x's. They're not x plus 1s or anything. So no units. Did it go up? It went 2 up. Now, answering questions from a graph that deal with extrema and lots of things we've done. So this question can get involved. There's not a lot of calculation, but there is a lot of thought that goes into this. Is this an odd or even degree? So looking at this, the degree of this function has to be odd because it goes up on one end and down on the other. The leading coefficient has to be negative, okay? The domain of this function, -infinity to infinity. The range of this function is -infinity to infinity. Where is this function increasing, okay? It is increasing from there to there, from there to there. These are x intervals. So that is the x interval from -4 to -1. And the next x interval is from 1 to 3.1. Where is this function decreasing? This function decreases in this section here, this section, and this section. Those are 3 different intervals. The first interval is from -infinity to -4. The next interval is from -1 to 1. And the last interval is from 3.1 to infinity. Those are always x value intervals. Where is this function greater than 0? Okay, this is something we did earlier in the class. Where is this function greater than 0? So let's erase this. Greater than 0 means above the x-axis. That's happening here, here, here. So greater than, strictly greater than does not include this 0.1. So I'm going to have to break this up into, it's happening from here to here and here to here. Okay, so there are 3 different intervals. So where is it greater than 0? From -infinity to -5. Next interval is from -2 to 1. Next interval is from 1 to 4. Where is this function less than or equal to 0? So less than or equal to 0 below the axis. Right here and right here. And because it says less than or equal to 0, I got to consider that moment right there where it's equal to 0. So that is from -5 to -2. It also happens at 1. And then it happens from 4 to infinity. So that is where it is less than or equal to 0. Where is it equal to 0? It is equal to 0 at the point -5, 0. At the point -2, 0. These are roots or x-intercepts. 1, 0, and 4, 0. Okay. Is there any multiplicity? Okay, I can look at it, I can look at this graph and tell there is a multiplicity right there because I do not cross the axis. So there's a multiplicity of 2 at x equal 1. Okay, absolute minimum. Okay, if you look at this graph, there's going to be no absolute min or max, okay, because it goes up without bound and it goes down without bound. So in the absolute min, absolute max, there are none. Relative minimum. So every minimum or maximum I see now is a relative. So there's going to be a relative minimum. It looks like 2 of them. -4, -8, and 1, 0. So -4, -8. So relative min, -4, -8, and 1, 0. Relative maximum. Go look at the graph again. So where do I find the relative maximum? There are 2. -1, 1.6, and 3.1, 3.3. So -1 is it's 1.6, -1, 1.6. And the next one is 3.1, 3.3. So those are the extrema, relative max and min. You can omit this. Anytime it says use your TI Inspire to graph, we omitted that section. So we are not covering that right now. And let's take a look at this graphical transformation. Describe the transformation from the left to the right, getting from F to G. So what I need to do is mark some point as a reference, okay? Let's just say, for example, let's take this point right here as a reference, okay? Where could I find that on the new graph? On the new graph, that is sitting right here, okay? Well, the shape is the same, so it doesn't look like there's any reflection about the x-axis. Did it move horizontally, okay? So if you go over here, this is where my point originally sat, right there. Okay, how do I get from this point to the next one? It looks like I have to go left 2, 1, 2, 3, 4, and down 4. So it looks like I have to go left 2 and down 4 to make that transformation. And that is it.